Hello there Year 9s, Mr. Herman here. This video will be looking at the worksheets that were provided to you during my absence last week. This was on the 14th and the 15th of July, which was Wednesday and Thursday respectively. First worksheet we're going to look at, standard form puzzles. If you've already approached these questions and you've got the answers to this, you do not have to watch the rest of this video. You can just simply correct this at work. The solutions can be found in the resources tab within Compass within our class in the respective folder of topic 5 indices. Let's have a look at this question here. What we'll be looking at is how to approach these scientific notations, how to put them in order from smallest to largest. They're chunked up in groups of 5, so you don't have to do every single one from smallest to largest, just the first group, second group, and third group separately. I'll be looking at how to approach the first group and the start of the second group, with the hope that you know how to approach the third group. Now there are two ways that we can approach this. We can actually write what the basic numeral of the scientific notation form is and then order it from smallest to largest. While this approach is deemed the easiest out of all of them, it's not the most efficient. Okay? The most efficient way to approach this is to look at the power of the base 10 of each of these numbers. The smaller the power, the smaller the number is going to be. Okay, so consider them as factors. We are multiplying 4 by 10 to the power of 5, or by a factor of 5. So there's 5, 5, 6, 7, and 6. These two are smallest out of all of them. And then from these two, 3.11 is considered the smallest out of them. So my first one is 3.11 times 10 to the power of 5. This is because 3.11 is smaller than 4. Okay, so you always check your base 10 power first, 5 and 5 being the smallest out of the whole group of 5, and then see what the next number is out of them is considered the smallest out of the two, or however many you have. Next number, 10 to the power 5. So cross those two off. Next, we've got powers of 6, of 7 times 10 to the power 6, and 3.2 times 10 to the power 6. Out of the two, 3.2 is smaller than 7. So 3.2 times 10 to the power 6 is next, and then 7 times 10 to the power 6 follows. Lastly, 3.1 times 10 to the power of 7 is your last digit. Now, if you want to double check this, just to make sure, you can expand this out. You can write the full version of this number, or the basic numeral version of each number, and you can test to see if the order is correct. Now, the second group, I've got to be careful because the powers are negative. Now, that's not to say that, remember, our solution is going to be negative. It just means that our solutions, when expanded out, when you write the basic numeral version of this, we'll start with a 0 point, and then a certain amount of zeros, and then whatever the starting number is. Okay, so just keep that in mind, but the concept is still the same. We're going to be looking for the smallest power of base 10. Now remember, we're dealing with negatives. Okay, so the smallest power out of all of them is -4. 10 to the power of -4 will produce the smallest, because this is going to provide that many leading zeros after the decimal point. Okay, where these ones here, this will only give me 2 leading zeros after the decimal point. So I know this one is going to be greater than these two here. I don't even know what the starting number is. It doesn't matter. All I know is that power of -4 is going to be considered the smallest. Now, from these two, we have a 5 being multiplied by this and a 4.1. We're going to be looking at the smallest of the two, just like we did in the first one. So in this case, 4.1 times 10 to the power of -4 goes first, and then 5 times 10 to the power of -4 goes second. Okay, and just to double check, if we were to expand this out, this is going to be 0.00041 and 0.0005. So from these two, the smallest out of the two, the smallest is 0.00041. Okay. Now you can go ahead and use this concept or this skill to fill out the rest in order from smallest to largest. And then you can go ahead and apply that logic for the last one. Now just be careful, this here is a 3, so a bit of a spoiler alert, this is 3 times 10 to the power of 0. Okay, because any number to the power of 0 is 1. So this is just named 3 times 1. Now you can use this as a bit of a guide to help you out the ordering of the powers with base 10. The second part to this is looking into what teragrams, gigameters, and picoculums, I believe is the pronunciation of this. I remember hearing this ages ago when I was at school in science class. Totally forgot. We're going to be looking into how to convert one of these to another. Now, I did say to the teacher that was taking this class that you can use your laptops to find the definitions, not necessarily the definitions, but the conversions of teragrams, gigameters, and picoculums if you needed to, if you didn't know what they were. And chances are that some of you, if anything, all of you would have done this. So what this means is we'll just look at the first one and then you can go ahead and apply the second one and third one. This is saying 5.98 times 10 to the power of 24 is the mass of the Earth. Okay, it's estimation. So this is in kilograms, and we're going to do a conversion from kilograms to teragrams. Okay, if you were to do a quick Google of this, what we do know, and what we can find out, is that one teragram is equal to 1 with 9 leading zeros afterwards kilograms. Okay. Or in other words, 1 teragram is 10 to the power of however many zeros there are, in this case 9. So 1 teragram is 10 to the power of 9 kilograms. 1 times 10 to the power of 9, so just 10 to the power of 9. So we need to write this format in teragrams, and if we know there are 10 to the power 9 kilograms in 1 teragram, we need to find how many lots of 10 to the power of 9 goes into this here. So in other words, we're going to get 5.98 times 10 to the power of 24, and we're going to divide this, or split this up into 10 to the power of 9. So we're going to say how many 10 to the power of 9 go into this. Now, the thing is we know the indices rules of division when it comes to powers. 10 to the power of 24 divided by 10 to the power of 9, that's the same as writing 10 to the power of 24 taken by 9, isn't it? So what we end up getting is 5.98 times 10 to the power of 15. This is how many teragrams there are. This is how many teragrams there are within 5.98 times 10 to the power of 24 kilograms. Now, of course, we're expecting this power to be less, okay, because we're chunking this up into 10 to the power of 9. So we're saying how many are there? Well, there's this many. Yeah. Okay. Now, it can get a bit confusing because you're dealing with these powers, but if you were to extend this out, write this as an expanded version, and write this as an expanded version, every 0 that you get on the bottom can be crossed out with the top. And you'll keep doing this till eventually you'll have 15 zeros left. Now what we're going to do is you're going to use that, or you guys, or we guys, or everybody is going to use this logic. You're going to find out how many gigameters there are within a meter, or how many meters there are within a gigameter. And then again, you're going to divide this, or split this up accordingly to write the proper version of this in gigameters. And then also with picocoulombs. Okay, you need a bit of direction, you can always look at the solution sheet for this. The last part of the worksheet had you looking into figuring out what these numerical answers are from scientific notation, either multiplication or division. Now, the concept of this is the same as a previous one, where if you have a base 10 with a power, you either add or subtract if there's a multiplication or division respectively. Look at the first one. We've got 3.0 times 10 to the power 6, all in brackets, and they purposely put this in brackets to show that this is one separate entity, and this is being multiplied by 2.0 times 10 to the power of negative 3. Now the cool thing about this is you can either A, put this into your calculator to figure this out, which is allowed, and it will spit out a numerical answer. Okay, so you'll go ahead and just put this into your calculator. Now the other way that you can do this is, again, you can write this out in the expanded version, and you can figure out what the answer is from there. The other way that you can do this, and this is probably the most preferred way, is because multiplication is communicative, meaning that meaning that you can, for instance, 1 times 2 times 3 is also the same as writing 2 times 3 times 1, which is the same as 1 times 3 times 2. There are different ways that we can write this. Doesn't work with division, dependent on the layout of the division, but generally speaking, for multiplication, you can go ahead and do this. We can rearrange this in such a way to make this easier to read and then easier to work out. In other words, I can do 3.0 times 2.0 for the first part, and this can be multiplied by 10 to the power 6, that's 10 to the power negative 3. And now with this logic in mind, I know what 3 times 2 is. This is 6.0. And we have the same basis here for this part here. When we are multiplying with the same basis, the powers get added. So this is 10 to the power 6 plus minus 3. We've got a plus and a minus. So this changes into a minus or a negative. 6 take away 3 is 3. So this is 6.0 times 10 to the power of 3, which is 6, 0, 0, 0. 6,000. Okay, so moving the decimal point to the right 3 times. 1, which is over here, 2, 3. 6,000. So let's go back to the little section on the bottom. 6,000 is this one here. That is the letter A. Now the other question we have here, where we have a division, which is the next one. This is 9 times 10 to the power of 5 divided by 3 times 10 to the power of 3. When we write this, I'm going to split this up into 2 parts again. I'm going to put the 9 and the 3, but instead of the 9 being multiplied with the 3, the 9 is going to be divided by the 3 because of this division that's in the middle here. So I'm not going to write this out. I'm just going to write the answer straight away in 2 lines. 9 divided by 3 will give me 3, or 3.0, and 10 to the power of 5 divided by 10 to the power 3. This is just times 10. When there's a division, the powers get subtracted. So it's the opposite of the multiplication. The powers get subtracted. So it's 5 minus 3, which is 2, 10 to the power 2. So 3 times 10 to the power 2, that's just 3 times 100. That's 300. Or in this case, a decimal point moves to the right twice. 1, 2, 300. So the number 300, which is over here, gets the letter H. Based on this here. You'll go ahead and answer the next set questions. Sometimes these numbers pop up more than once. So again, here I missed out. This is another 6,000. So this is also A, which was the first question we worked out. So just be careful of that. But you will figure that out. By the time you get to the end one, you'll know that there are some letters that are missing. You'll just go ahead and fill them out based on what you have missed out on. This is the first worksheet. I'll make a separate video for the second worksheet. See you guys then.